we're going to work to understand the basics of conditional probability. So conditional probability is exactly what it sounds like. Given some condition, what is the probability that an event takes place? Well, here we have a smiley face, a card, we'll pretend these are cards, and we have two cards with a triangle. So I'm going to say S equals card has a smiley, T equals the card has a triangle, and we know right away that the probability that if you were to randomly draw these, shuffle them up and draw one, the probability of getting a smiley face would be 1/3. Similarly, you could say the probability of getting a triangle would be 2/3. So that seems to make sense. That constitutes the entire sample space of 100%. Alright, well now suppose that we remove one of the cards. So let's just say we want to know the probability of a smiley face given that you know, your friend told you that a triangle was removed. Okay, well if you know that out of the pile a triangle was removed, so imagine putting a slash through one of these triangles, what is the probability that you get in the next draw you get a smiley? Well, because you only have two cards left, you've removed one of them, and there's only one smiley face left over, well, there's a 1 out of 2 chance that the second draw will result in a smiley. Similarly, if you're looking for the probability of randomly drawing a triangle, given that the smiley has been removed, well, if you've removed the smiley, then your sample space, your things to draw from, is now 2 and not 3 because this guy is gone. And out of those, what's the probability that you get a triangle? Well, that is exactly what the remaining two cards are, so there's actually a 100% chance that I draw a triangle if the smiley face is removed. This is the basic idea of conditional probability. We have some condition, provided that something happened, tell me the probability of the event. Now you'll notice that these two things are different. This one does not have any condition placed on it. This one assumes nothing has happened yet, whereas this one assumes that the condition has already taken place. Now if I asked you, for example, sometimes it's irrelevant, like what's the probability of drawing a smiley given that that the Dow Jones is up 10 points? Well, the probability is still going to be 1/3 in that case because the condition is irrelevant to the experiment. So irrelevant. So that wouldn't matter in this case. Okay, well let's take a look at another similar situation. Suppose you have 10 fish in a pond. You have 2 blue fish and you have 8 black fish for your total of 10 fish. Okay, well, so now let's just say we want to find, we're going fishing in this pond and we want to know the probability of getting, so we'll let B equal blue. I guess we'll have to do K, we'll let that be black, for lack of better choices. So the probability that we get a blue and black fish in that order. So a blue fish the first catch, a black fish the second catch. Well, in this case we can't simply just say that this is going to be, so this is not equal to 2 out of 10 times 8 out of 10, because the fact that we catch a black fish on the second try is conditional upon what happened the first time around. So in fact, we cannot just do the probability of the first fish being blue times the probability of the second fish being black, because they're dependent on one another. That is to say that we should be doing the probability of a blue fish is 2 out of 10. But now that we've already fished out one of those blue fish, the probability has been modified. So we've already fished out a blue, so that guy's gone, let's say. Well, now the probability of catching a black, well, there's still 8 blacks left in the area, but there are only 9 fish left in the pond. So the probability